Hi guys, welcome back. Today I want us to look at electric circuits where there is internal resistance within the battery, and let's say ignore or resistance in the wires is negligible, right? So we already know that when it comes to internal resistance, we're talking about opposition to the flow of charge that we find within the battery itself, right? Let's make this to be 4 that we find within the battery itself, right? We're given a circuit here. It says there's internal resistance in the battery, and then it says when switch S1 is open and switch S2 is closed. So let's say S2 is closed and S1 is open, right? What does that mean? Before continuing to read the whole statement, the whole scenario, all the sentences that are there, analyze it bit by bit, right? So S1, if S1 is open, what are the implications? What does it mean? If S1 is open, then S1 is like a main switch. Like if you think about it, at home you have a main switch. Main switch is in, if you go to the switchboard and you switch everything off, that's a main switch, right? Then you also have a switch in your room where you can switch on and off the lights, on and off specific wall sockets, right? Think of it like that, to say, when I'm looking at a switch, what is the effect of opening it or closing it on the rest of the circuit, right? For instance, if you look at this one, S1 is like a main switch in the sense that if S1 is open, there isn't any current that is going to flow in the circuit. However, if S2 is open, if S1 is closed and S2 is open, there will be a pathway for the current to flow, because the current can flow here, right? The current can flow here, all the way here. However, now they're saying S1 is open and S2 is closed. Even if S2 is closed, if S1 is open, the main switch, then there won't be any current that is going to be flowing in the circuit, right? They say the reading on V1 is 24. So that reading, it must be the EMF, which is the reading across the battery when there is no current flowing in the circuit, right? It must be the total energy that is supplied by the battery, which is 24 volts. And then they say when S1, both S2 and S1 are closed, so now I've closed both of them, which means there must be current in the circuit, right? Then the reading on A1 is before the current splits. So it means that, sorry about that noise. So it means that A1 must be it must be reading the total current, right? And then the total current, we are given that it's going to be equal to what? 3 amperes. And then we are also told that the reading on A2 reads the current in this branch, because the current is going to divide here at this point, right? Some of it goes in this branch, some of it goes in this branch. Because 3 ohms is a lower resistance than 6, then more current goes through the branch with the 3 ohms, which means A2, they're saying the reading is equal to 2 amperes. 2 amperes, right? So since we've taken from the 3 amperes, we've taken 2, it means 1 ampere must be the current flowing in this branch, right? Clear. Then, moving on from that, the rest, this part that are highlighted in green is the total current flowing through it. So it means through the 4 ohm, there must be the total current flowing there, which is going to be 3 amperes. So analysis is very important when you're dealing with circuits, and breaking it down in terms of current, in terms of potential difference, in terms of current, in terms of potential difference, in terms of resistance as well, right, is very, very, very important. It's very important for you to do that. So if you look at now this circuit, let's break it down and narrow it down so that we are able to go further, right? So if we narrow it down, what are we going to have? We have this 3 ohm that is parallel to the 6 ohm. What does that mean? That means if I was to put a voltmeter here across this one, it is called VP, and a voltmeter here across the 6 ohm, they should be having the same reading. Why? Because V 3 ohms and 6 ohms are parallel to each other, which means the potential will not divide. The potential energy will not divide. What is going to divide is the current, right? And then now another important thing to note is, so since the total current divides here and then merges again here at this point, it means I can be able to say that this parallel connection is in series with this 4 ohms resistor, 4 ohm resistor that I have here, right? Why? Because when I combine these two, then it's the total current that is flowing through them combined. And then it's also the total current that is flowing through the 4 ohm. So those two, they must be in series, right? The RP is in series with the 4 ohm. I hope that is very clear. And then now, they say those are the readings that we are given. Another thing that is important to note, now in terms of the potential difference is, in as much as these two, the 3 ohm and the 6 ohm, have the same potential difference, but the potential difference divides between the RP and the 4 ohm, right? So if I was to write it as a mathematical relationship, this is important, right? In terms of resistance, what do I have? To get the R external, I must first add R parallel plus the R which has the 4 ohm, right? And then in terms of now potential difference, how are the different the potential difference across the different resistors? How are they linked? What I have is the V external would be equal to V parallel plus V for the 4 ohm, right? That is how I would get the V external. Remember, as I'm speaking about V external, remember that since we have internal resistance, right, there is energy that is used up within the battery. What does that mean? It means that the total energy that is supplied, the EMF, some of it is used up within the battery, V internal, and then some of that energy, the remainder of that energy, it goes out into the rest of the circuit, the external circuit, right? So that's why I'm now referring to V external. That's why I'm now referring to V external. Now, if you look there, those are some important things that I've done while I'm analyzing, right? Let's say now I'm given a question, and in the question they say that I must determine the internal resistance, right? I must determine the internal resistance. There's many ways to approach it. I'm going to show you just one way. How can you determine the internal resistance in this situation? So you must always begin with the end in mind, right? In the sense that to find the internal resistance, there's a couple of things that I'm going to need. One, I'm going to need either the voltage, the V internal, or I'm also going to need the current that is passing through the battery, which is equal to the total current, right? So that I already have. But this V internal I don't have. I definitely do not have. But another thing is I may not necessarily need to find the V internal, because why? I can be able to expand this equation. This equation I can expand and write it like this. IR plus V external. right? But I'm definitely going to need to find the V external. So how can I do that? This is one of the ways in which I can approach this question. We've already spoken about this. Remember this? So let's go back to this. How can I find V parallel? V parallel, R is equal to V over I. I can use one of these branches. I can use one of them because remember I said it's going to be the same, right? So that's going to be 3 ohm, and that's going to be V parallel, and I'm going to use the current of 2 ohm for this branch, and I get V parallel is equal to 6 volts, right? And then what about the V across the 4 ohms? I can get that by saying R is equal to V over I again, I total, and then I can use the 4 ohm and get the V, which V is equal to 12 volts, right? Which means now I can be able to take these values to the V external. That would be 6 plus 12, which is going to give me 18 volts, right? I've got this, I've got this, I've got this, which means I can be able to calculate the internal resistance. All that's left is substitution. 24 plus is equal to 3R plus 18. Then I can do my transposing, and the 6 I'm going to divide it by 3, and R is going to be equal to 2 ohm, right? I hope that was helpful to you. Please subscribe and refer to your friends who may also find this helpful. Analyze well. Spend time analyzing each variable, current, in terms of current, in terms of potential difference, in terms of resistance, and circuits will be like a breeze. See you on the next video.